So let's look at some practice problems for Euler's method. I'll go through 3 examples. 2 of them are really great examples of Euler's method, and one of them is an interesting example of what can go wrong in Euler's method. So I will post the links to each problem in the description if you want to jump straight to the beginning of a problem or skip to the next problem. So first one, dy dx equals y with initial condition y of 2 equals 3. Use Euler's method with 2 steps to find y of 4. So I will make a table x, y, and dy dx. And I start off at 2, 3. Now I know that I'm going from 2 to 4, so the interval is 2 units wide, and I want to use 2 steps, so that change in x for each step, which a lot of references call h, is going to be 2 divided by 2, which is 1. If you need more info on this, I made a video explaining it better, but that means that I'm going to go from 2 to 3 to 4. And now, dy dx is just y is 3, and I'm making a linear approximation, so I'm going to start at 2, 3, and go with a slope of 3, 1 unit to the right. So that means I'm going to start off with my y value of 3. So the first new y value is going to be my old y value, 3, plus my change in x times my slope. Okay, that y1 equals y0 plus h times dy dx naught. So in here, I get 6. And looking at the graph, I'm starting at 2, 3. I make a step of slope 3, 1 unit to the right, and end up at 3, 6. And I continue. So now the slope is 6, and I get to my second y value by doing my previous y value 6 plus my change in x times my new slope, which gives me 12. And showing that on the graph, I take a step right with a slope of 6 and end up here at 412. And I actually know the solution to this. The solution is actually this. You can see it sort of follows the trend. Again, this was curved. These are straight. That's why, since it's concave up, the tangent line will be below the curve. And if I wanted a more accurate estimate, I could do more smaller steps. So my estimate of y of 4 is that it's approximately 12. Example 2, dy dx equals 2x minus 3y with initial condition y of 1 equals 1. Use Euler's method with 3 steps to estimate y of 7. So I'll make my table x, y, dy dx. I'll start off at 1, 1. And I know that I'm going from 1 to 7, so the whole interval is 7 minus 1, 6 units long. That means that my change in x, which I'm going to represent, or a lot of references represent as h, will be the overall change divided by the number of steps, which is 2. So I'm going to go from 1 to 3 to 5 to 7. Now here, things go actually badly because of how large these steps are. So let me show you what's happening here, and then I'll show you the actual solution and explain what happened again. So in here, 2x minus 3y, 2 minus 3 is negative 1. And so I take my previous y value, which is 1, and add on my step size times the slope. It's just dealing with the tangent line. And I'll get that my new y value is negative 1. And so in the graph, let me clear off my old graph. So get rid of all this junk. All right, I'm at 1, 1. And I take a step right 2 units with a slope of negative 1. So that gets me here. And you might think, okay, this looks fine so far, but here's where things get bad. So I follow the same process. 2x minus 3y, well, that's going to be 6 minus negative 3, which is going to give me 9. And y2 is going to be the previous y value, negative 1, plus the change in x times the new slope, which will give me positive 17. And so I go to the graph, and now I jump up. So I take a step right 2 units with a slope of 17. I'm way off the graph up here. And then I go through the same process, and I say, okay, 2x minus 3y, well, 2 times 5 is 10. So let's say 10. 3 times 17 is 51. 10 minus 51 gives me negative 41. And I say that my third y value, which is the last step I'm going to need to take, will be my previous y value, 17, plus 2, the change in x, times my slope. 2 times negative 41 is negative 82. Negative 82 plus 17, that's going to give me, let me think, negative 82 goes to negative 75, negative 65. And so, I'll show that on the graph. And now, from way up here, I now take a step right 2 units with that other slope. I dive way down here and get to 7, negative 65. And looking at this graph, it doesn't look right at all. So here's what happened. You can see clearly we have the tangent line. But if I actually look at the slope field for this, it's going to be one where everything is pushing towards this tangent line. Unfortunately, my steps are so big that I vastly overshoot. If I were actually at this point, I would start with the slope, but then quickly approach that tangent line slope here, which is going to be 2/3 from the 2/3 x. Everything else doesn't make a big difference as I go towards infinity. So the problem here is I take steps that are way too big and overshoots, and then greater overshoots, and it's just going to get worse and worse. If this were to happen in the real world, we would know to take much smaller steps so we actually follow the curve and don't end up crossing what's going to be this sort of slant asymptote here at, I think that's going to be y equals 2/3 x minus 2/9. So that's what happened there. Still, we did the process correctly and got our approximate for y of 7 to be approximately negative 65. But this is a very bad estimate for the reason of how quickly this slope changes when I change x or y by a relatively small amount, and by the fact that this change in x is so large. So I will be taking very large x and y steps. That's going to sort of throw this off very quickly. All right, so one more example. dy dx equals x minus y with initial condition y of 1 equals 1. Use Euler's method with 4 steps to estimate y of negative 1. And this is actually a much better approximation. So make my table. Start off at 1, 1. And the reason it's much better, for 2 things, being just 1x and 1y here, it doesn't change as drastically quickly. And if I'm starting at 1 and ending at negative 1, so negative 1 minus 1, my interval size is -2. I actually go back 2 units. And since I'm doing 4 steps, my change in x, or that h value, is going to be -2 divided by 4, which is -1/2, which is a much smaller step than the last problem. So those are the 2 reasons this will be a much better approximation, because these aren't changing as quickly and my step size is much smaller. So I go through the process. If my step size is -1/2, I go from 1 to 1/2 to 0 to -1/2 to -1. So 1, 2, 3, 4 steps to get to -1. And I follow the process. X minus y is 0. And so to get the next value here, I do y1 equals my previous y value, which is 1, plus my step size, which I guess is actually going to be -1/2, so I'll just write it that way, -1/2 times the slope, which is 0, and I will get a 1. Graphically, I'm going to clear this stuff out. I'm starting at 1, 1. I take a step size of 1/2 with slope 0 to the left, and I end up at 1/2, 1. And I continue, same process. So in here, x minus y gives me -1/2. I get y2 equals 1 minus 1/2 times the new slope, -1/2, which is the same thing as 1 plus 1/4, 5/4. And let's look at the graph. So I take a step size of a half length left with a slope of -1/2. I end up at 0, 5/4. And I continue. So same process. I do x minus y to get my new slope, which would be -5/4. My third calculated y value will equal my second calculated y value, 5/4, minus 1/2, which is my step size, times the slope. -1/2 times -5/4 is positive 5/8, plus 5/4, which is 10/8, gives me 15/8. And looking at the graph, I take a step size of 1/2 to the left, end up at -1/2, 15/8. And one more step. So in here, I do x minus y to get my slope. -1/2 minus 15/4 is going to be -15/8 is -19/8. I calculate my fourth y value, which is my previous y value, 15/8, minus 1/2 times the new slope, -19/8. -19/8 times -1/2 is positive 19/16. 15/8 is positive 30/16. And so when I add that up, I get 49/16. And looking at the graph, take a step size left of 1/2 with slope -19/8. And I get to -1, 49/16. And if I look at the graph, the actual solution looks like this, and you can see, okay, it's pretty good. You know, it shows the trend. We are off a little bit because this is concave up, so the tangent lines are going to fall below the curve, but that's the process, and so the approximation I get here is going to be y of -1 is approximately 49/16. Okay, comment below if you have any questions.